Alright class, welcome to the Math 2020 Test 1 review video for today, class on June 1st. And we have some requests here for problems to be worked out. Number 2, 7, 9, 13, 14, and 15. So I copied number 2 figure below. As you can see, we'll go ahead and start with number 2. And down there. And part A says, name the objects using the diagram on the right. Okay. So we're going to name some points and lines and segments and such. First of all, in part A, it says, how many lines can be drawn through both E and D? Okay, so we have this figure, E and D. And these are 2 points on my figure, and there can be only one line drawn through E and D. Okay, so they come out like this. E and D. Okay, so we can only draw one line through those. From that here. You can draw that with blue. Okay, so that's the line that you have. E and D, so I only drew part of that figure. There we go. Name 3 points that are non-collinear. So part B, non-collinear means that they're not in a line. Not in a line. Okay, so they could be like any number of things. So you have points D, G, E. Okay, those ones are not in a line. A, G, B, A, B, C, and so on. Part C says name 2 rays. Now, ray is a geometric figure that has a starting point but no ending point. Okay, so we can start at G if we wanted. Center is a good place to start. So we could have array GB. We can have array GA. Okay, all of those start at one point and do not have an end. Part D says that we need to name 2 supplementary angles. Now, supplementary are angles that add to 180 degrees. Okay, again, in our figure, there's a variety of things that we can use. They just have to be 2 angles that add to a line. So, angle DGF, for example, plus angle FGA. There, so that's at the top. Those 2 add to 180. Okay. So those are 2 angles. Name 2 complementary angles. So in part E, complementary they add to 90 degrees. Okay, so let's look at our figure. Now on the right side, left side, we have angle DGE and angle EGF. Okay, so those are 2 examples there. So that's number 2. Next is number 7. Now number 7 has activities that we've done in class to help students discover geometric properties. Okay? So in part A, describe how students can show that the sum of the measures of the angles on a line is 180 degrees. Okay, we want to discover angles on a line. So we can use what we've done in class as a guide. So what we did in class was we drew a line, draw rays from the line. Let me try to write this here. Thank you. And we're going to measure the rays with a protractor. Well, the two rays that make the angles, that is. So we want to say measure angles formed by rays with a protractor. Then sum the angles measures. Okay. Part B, describe how students can discover that the sum of any angles in a triangle is 180 degrees. Okay. So angle sum of triangles we're going to discover. Okay. And in class we cut out a triangle. Then we cut off the angles. And then we lined the angles up. So they were adjacent or next to each other. We noticed that they formed a line. Okay, so part C. Describe how students can discover that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay. So this is exterior angle of triangle property. And the first thing is we cut out a triangle. We cut off two angles. Place them adjacent to the third and notice that they fit to form a line. So adjacent to the third angle is where the exterior angle is. Okay, and then notice that they fit the exterior angle perfectly. Part D says, describe how students can discover that vertical angles are equal. Okay, so vertical angles. We want to draw two intersecting lines. Measure one angle and use angles on the line property to find the measures of all the rest of the angles. Okay. Okay, so first, well, we kind of want to notice that there are 4 angles around the 2 intersecting lines. Then we can do the measurement. You measure one angle and use angles on a line. Okay. Sorry about that. To find the rest. You want to notice that the angles across from each other are equal. Okay. Part E. Describe how students can discover that the opposite angles in a parallelogram are equal. So you cut out a parallelogram. So this is opposite angles. Okay, fold the fold the parallelogram into fourths. And then notice the opposite angles match. Okay, and the last one, describe how students can discover that the interior angles in a parallelogram or trapezoid are supplementary. Okay, so this is interior angles. So they want to cut out a parallelogram or trapezoid. And then from there, you want to cut it in half. Slide the bottom half to the top half. And notice the angles are supplementary. Okay, great. So the next one after that, after number 7, is number 9. Alright, so number 9. Number 9 has 3 figures that are quadrilaterals. We want to give a definition and classify them, or name the quadrilateral. So part A has this figure here. It's tall and skinny. Okay. We are also given that the sides are parallel. Okay. And if there's only 2 sides that are parallel, we call this a trapezoid. Okay? A quadrilateral with one set of parallel sides. Okay? Part B. All the sides are 10 units. All the angles are right. So this is a square. Okay, so we'll draw that out here. Okay. Notice that all of the angles are right. All of the sides are 10 units. So this is a square. Okay. We have the definition of a square as a rectangle with 4 equal sides. Or a rhombus with 4 equal angles. 4 right angles, let's say, to be more precise there. Okay. Part C is a kite. Okay, so it's a kite. I'm drawing a little bit on its side here. There you go. This side and that side are equal. This side and this side are equal. Okay. So the kite looks like a flying kite that you fly. So the definition is a quadrilateral with 2 sets of consecutive equal sides. Okay, so there's number 9. After number 9 was number 13. Number 13 is a teacher solution or proof. So we want to find the measure of angle x. I'm going to draw this figure here. And on the top of the figure we have an equilateral triangle. All those sides are staying. And then we extend the side here to have a base angle, and we extended it far enough so that it is the same measure, oops, back there, as the sides of the equilateral triangle, and then we complete our figure that way. What we are given is that this angle here is x, and that's about all. What we need to do is we need to find the measure of angle x. So first we want to write a plan. Okay. And so our plan, we know that the triangle given is equilateral, which means all the angles are the same. We also know that the bottom triangle is isosceles. Okay, so we have it for these marks here. Okay. So what I'm going to do is I'm going to use blue marks. This is isosceles triangle. Okay, it's in blue. When you have an isosceles triangle, you have one property that's automatically given to you. Okay. So if you have an isosceles triangle, we know that the base angles are the same. Okay. And so this angle here must be x as well. I'm going to do it in red. That angle is also x. Okay. Now here one might get stuck, but when you get stuck on a plan, look for the dark horse property, I call it, which is the exterior angle of triangle. Okay. So the exterior angle of a triangle, I'm going to highlight in green. So to this blue triangle, I have a green exterior angle, which is this one. And that exterior angle is equal to the sum of the two opposite interior angles. So this green angle is exterior to the blue triangle. So that must be that the opposite two interior angles, which I'm going to circle in green here, are this x and this x. Okay. So we want to use, so our exterior angle property gives us, well, let's see, gives us that angle equal to 2x. Well, what is that angle? Well, let's label it. So put some points on here. This is A, B, and C, and they didn't put any points on, so I'm going to put my own on. And that'll be D. Okay, because of exterior angle, we have that angle ABC is equal to 2x, because there's x plus x that I've circled in green. Okay. So when that's 2x here, I know that by equilateral triangle, this is equal to 2x and this is equal to 2x. They're all the same angle. Okay, so equilateral triangle means that angle BAC is equal to angle BCA, which is also equal to 2x. Okay? Now, since all of those angles are equal to 2x, we can, in the top equilateral triangle, we can go ahead and add them together. So we're going to use angle sum of triangle, which will give us 2x plus 2x plus 2x equals 180 degrees. Okay? We can solve it from there. Alright, so that's my plan. What I'm going to do now, I'm going to get teacher solution on this side. And the teacher solution will go along with our plan. So first we needed those two angles to be x, the black x and the red x. And so we can say that we don't know what the red x was at first, so we will name it a letter. We'll say A. And we can say that A is equal to x because of base angles of isosceles triangle. Okay. And once we knew that the x was there, we used our exterior angle to get angle ABC. Okay. So angle ABC is equal to 2x by exterior angle of triangle and then we know that angle BAC is equal to angle BCA, which is also equal to 2x by equilateral triangle property. Okay. And then we go to angle sum of triangle, which we added all of the two x's together, 3 sets of them. That's equal to 6x, that's equal to 180. And I can do that because of angle sum of triangle. And so now we have 6x equals 180. X is going to equal, I'm going to divide by 6 on both sides. And therefore x is going to be 30 degrees. Okay. So that was number 13. You guys can pause the video there and look at that if you need. Okay, number 14. Number 14 has another proof where we have a few triangles. Okay, so we're going to draw that one on here. This thing is more of an angular. There we go. Now that bottom line continues out through here. That continues out through here. This continues over here. There's that one a little bit more. Okay, there we go. We do have some points that they're given to us. B is on top. A is on the left side. E in the middle. C and then D. Okay, they give us some angles. 2x is here. 40 degrees is here. X is down here. 2x is also here. And 40 degrees is here. Okay, so we should have everything there. Now, I'm going to scoot this one over a little bit. Just room for our teacher solution. What do we have here? There's lots of stuff here. Make a plan. We need x. So our plan, we have angle, these two angles here have 2x with them. Okay. And we know that this green triangle, if we extend its base, we can get an exterior angle off that one. Okay, so with the exterior angle, we know that angle BEC is equal to 4x. So I'm adding the 2x and 2x together. So I'm going to go ahead and label that in there. Okay, so I have triangles here, so I'm probably going to use an angle sum of triangle property. It'd be nice to get this angle here. Okay, now that angle and that triangle, I'm going to highlight in red. Has another triangle at the bottom of it. So I'm going to highlight that one in yellow. So the bottom triangle has two opposite angles there that are x and 40. Okay, so let's try and look at exterior angle again. I'm going to add my x and my 40 and get the other angle here. So angle BCE is equal to 40 plus x because of the exterior angles. Okay, so I'm going to write that in there. Alright, so then I have all three angles in this middle triangle. So angle sum of triangle. We're going to use the 40 degrees plus 4x plus 40 degrees plus x. Okay, set all that equal to 180 degrees. Okay, and when we do that, we should be able to get our answer. Okay, so let's go ahead and do our teacher solution. Now, our first step in the teacher solution was to find these exterior angles. And so I can say that angle BEC is equal to 2x plus 2x. Okay, I list my exterior angle first and then put it with the sum of the opposite interior angles. So exterior angle of triangle. Okay, so angle BEC is equal to 4x. Next, I've got the angle BCE. That's going to be equal to 40 plus x, because those are the red angles that are circled there because of exterior angle of triangle. Okay, so we have those equal to each other. Now the 40 was given to us, and so I'm going to circle that again in, let's circle it in purple. We're going to do angle sum of triangle with this angle, and this angle. Okay. So we have 40 degrees plus 4x plus 40 degrees plus x. I put those in parentheses because they are one angle. Set that equal to 180 degrees. And my reason is angle sum of triangle. Okay. So now we solve it for x. The 40s will add together, so will the x's. So we have 5x plus 80 degrees is equal to 180 degrees. 5x is going to equal 100 degrees. Subtracting the 80s, divided by 5, x is going to equal 20 degrees. Okay, so there's that one. Our last one is number 15. Okay, which also has a figure that we'll copy down. Okay, so it has a line coming down like that, and a line coming down like this. This line is extended out here, so it's the base extended. This line comes at a 90-degree angle here. That segment does, and then we extend out a 90-degree angle here, segment that way. It's at 90 degrees as well. Okay, so we have no points labeled, but I don't think we'll need any on this one. We have angles labeled though. This is angle x. These, of course, are 90 degrees. This is angle x here, and this is angle 3x here. So let's make a plan. Okay. We need to get, let's go ahead and try and get some of these angles for angle sum of triangle. So I have two triangles here. An angle sum of triangle would be helpful to have this angle here, this angle here, and this angle here. Okay. Now I think we can get at all three of those angles. Okay, so that I can find, so we can use the purple triangle here, angle sum of triangle on that one. Okay. Now the top angle has angles on a line. So this angle that I want, plus the 90 degrees plus the x, is equal to 180 degrees. Okay. So we'll use angles on a line. Okay. And we'll add those together. So let's label this one angle A. So on angles on a line, we'll have A and 90 and x together. And I can go ahead and solve it for A. 180 degrees minus 90 degrees minus x. Okay. So I'm solving it for A. And I simplify it. And 180 degrees minus 90 degrees is 90 degrees. So we have 90 degrees minus x. There. Okay, so we're using angles on a line. Now that's one angle. Angles on a line here, well, you do it again. So these angles also are on a line. Okay. Let's label this one angle B. What is B going to equal? we're going to use angles on a line again. So we have 3x plus b plus x equals 180 degrees. And we can add the x's together, so b plus 4x equals 180 degrees. So that's okay that that's an expression. B is going to equal 180 degrees minus 4x. Alright, so that's that one. And to get the last one, we also use angles on a line. Copy this down first. We can show that this angle right here is going to be angle C. So we use angles on a line to get angle C. So C plus 90 degrees equals 180 degrees. And then I subtract 90, so C is going to equal 90 degrees. Which we could have deduced, or we could have seen that from the picture, but we have to prove it. Okay. Now I have three angles that I can use angle sum of triangle. So in my plan, I'm going to use angle sum of triangle. Say, okay, 90 minus x, that's one angle there, plus 180 minus 4x, that's the other angle there. Move these back here. So we can add on the 90 degrees, set equal to 180 degrees. Alright, so there's my plan. I'm going to go ahead and draw my teacher solution out here. Okay. So we found the top angle, A, and we had to add A plus 90 degrees plus x equals 180 degrees. That's from angles on a line. We have next is the bottom angle, where we have 3x plus b plus x also equals 180 degrees from angles on a line. Then we add on, oh whoops, we need to solve for these here. Hold on one second. Okay, so if we set a and 90 and x equal to 180, we can solve it for a, because that's what the angle that we want. So I subtract off 90 from both sides, subtract off x from both sides. So a is by itself, and it's equal to 180 degrees minus 90 degrees minus x. And like we calculated before, the 180 minus 90 gives me 90 degrees minus x. So that's what a is equal to. Next we will relate our 3x plus b plus x equal to 180, angles on a line. And when I add the 3x's together, I get b plus 4x equals 180. And then we have b is going to be equal to 180 degrees minus 4x. Okay? So kind of have these things going here for these angles. So there's two angles there. The last angle was C plus 90 degrees equals 180 degrees from angles on a line. And then we have to subtract 90 from both sides. And C is going to equal 90 degrees. Okay. So there's my third angle. Now using angle sum of triangle to add all of these up. And so we have 90 minus x plus 180 degrees minus 4x plus 90 degrees equal 180 degrees. Okay, so we're adding all of those together. Let's add up the numbers. We have 90 and 80, 180 and 90. So the two 90s will add to 180, and that 180 is equal to 360. Then I'm going to subtract off 5x and set that equal to 180 degrees. So if we subtract off 360 degrees from both sides to get the 5x by itself, we get minus 5x equals minus 180 degrees. Divide by minus 5. Negative 5 there, and x, therefore x is going to equal 36 degrees. Okay, so there's that last problem. Okay, I'm posting homework or test 1 review solutions, example solutions, and you can look at those and also post these notes. And good luck studying for the test. Let me know if you have any questions. Send me an email, send me a picture with a work in progress on a problem if you need, or we can set up a Zoom conference.